According to 310.54 of the National Electrical Code, conductors connected in parallel are considered a single conductor, calculated by the total cross-sectional area of all conductors in parallel. This is a key point when determining the allowable ampacity of a wireway that contains these parallel conductors. The code treats the entire set of parallel conductors as one larger conductor for ampacity calculation purposes within the wireway. Now, let's address 310.15b2. This section mandates derating of conductors when the number of current carrying conductors in a raceway or cable bundle exceeds 30. However, because 310.54 treats parallel conductors as a single conductor, this derating requirement does not automatically apply to situations where you have more than 30 physical conductors in a wireway if those conductors are part of a parallel configuration. The important concept here is that you only count the number of equivalent single conductors, not the total number of individual wires. If the plan check review comments indicate a misunderstanding, it's crucial to provide a clear and well-supported response. The reviewer might be misinterpreting how the code applies to parallel conductor configurations. Since 310.54 explicitly states that parallel conductors are treated as one, the standard derating requirements for more than 30 conductors, as described in 310.15b2, don't apply in the typical sense. To address these concerns, formulate a written response that clearly explains your understanding of both 310.54 and 310.15b2 and how they relate to your specific installation. Emphasize that you've correctly applied the rule regarding parallel conductors being considered a single conductor. It might also be helpful to request a meeting with the plan check reviewer. This allows for a direct discussion about the code interpretations and provides an opportunity to clarify any misunderstandings. Prepare to present your reasoning logically and back it up with direct references to the NEC. Here are some additional considerations for your installation. Firstly, ensure that the wireway being used is appropriately rated for the total ampacity of all the circuits it contains. This is a crucial safety measure. You need to verify that the wireway can handle the combined current load of all 6 1000 amp circuits. Secondly, consider the mechanical support for the wireway. With multiple circuits and conductors, the wireway might be subjected to significant weight. Adequate support is essential to prevent sagging or any physical damage to the wireway. Make sure that the supports are installed according to the manufacturer's specifications and the relevant codes. Thirdly, ventilation requirements must be taken into account. A large number of conductors carrying high current can generate heat. Proper ventilation is needed to prevent overheating within the wireway, which could lead to insulation damage or other problems. Check the wireway manufacturer's guidelines and the NEC for ventilation specifications. When you calculate the ampacity, the 400 kcmil copper conductors have to be derated based on the terminations. Typically, with most terminations you are limited to 75 degrees Celsius, therefore you will have to use the 75 degrees Celsius column. The ampacity of a 400 kcmil copper conductor at 75 degrees Celsius is 335 amps. Since you have 3 of these conductors in parallel for each phase, the total ampacity would be 335 amps times 3, equaling 1005 amps. Since you are designing for 1000 amps, this is acceptable. For the 2/0 copper equipment grounding conductor, you have to look at NEC table 250.122. Based on the size of the ungrounded conductors, which are 3 parallel 400 kcmil, the equivalent size is 1200 kcmil. Therefore, using table 250.122, a 2/0 copper conductor is sufficient. Additionally, the wireway must be sized according to 376.22. The sum of the cross-sectional areas of all contained conductors should not exceed 20% of the interior cross-sectional area of the wireway. The cross-sectional area of a 400 kcmil conductor is 0.3722 square inches. With 54 of these conductors total, 18 for each phase, this will be 54 times 0.3722 square inches, equaling 20.988 square inches. The cross-sectional area of a 2/0 conductor is 0.1333 square inches. With 6 of these conductors total, this will be 6 times 0.1333 square inches, equaling 0.7998 square inches. The total square inch area of all conductors is 20.988 square inches plus 0.7998 square inches, equaling 20.8986 square inches. Therefore, a 12-inch by 12-inch wireway would be sufficient, as the internal cross-sectional area of the wireway would be 144 square inches, and the conductors would be 14.51% of the internal cross-sectional area. Remember, it is essential to meticulously document all calculations, code references, and decisions made during the design and installation process. This documentation will be invaluable when communicating with plan check reviewers or any other stakeholders involved in the project. Keep in mind that local amendments to the NEC can exist. Always consult with the local authority having jurisdiction, abbreviated AHA, to confirm any specific requirements or interpretations that may be in effect in your area. Their guidance is paramount in ensuring code compliance. Finally, this information is intended for educational purposes and does not constitute professional engineering advice. Always consult with a qualified electrical engineer or licensed electrician for specific design and installation guidance.